Hello students, let's learn more about polynomials. Today we will understand what are the zeros of the polynomial and their relations with coefficient and constant of the polynomials. You must remember in class 9th you have learned the zeros of the polynomial. The zeros of the polynomial are the value of the variable for which the polynomial reduces to zero. That means the value of x which when kept at its place, the whole polynomial becomes zero. So that means we want to reduce the polynomial equal to zero. So if you want to find out zeros of the polynomial, you will just put the polynomial equal to zero. So we kept x square minus 5x plus 4 equal to 0. Let's factorize it by breaking the middle term. It will be x square minus 4x minus x plus 4 equal to 0. Taking two terms together and last two terms together, you will factorize it as x minus 4 and x minus 1 equal to 0. Since children, the product of two numbers is equal to 0. That means one of them must be equal to 0. For example, suppose you have two numbers, 5 into, I'm giving you to fill up this blank so that the product of the two is equal to 0. Definitely you are going to put 0 here. Then only you are going to get the product equal to 0. Or if suppose I give the blank here and the second number as 6 and I want you to fill it up so that the product of the two becomes 0. That means again you are going to put 0. So that means if the product of the two factors is equal to 0, then one of them must be equal to 0. Same here, we have two brackets. The product of these two brackets is equal to 0. So either the first one is equal to 0 or the second one is equal to 0. So that means the value of x can be equal to 4, or this is a symbol for writing or it is equal to 1. Children, let us verify. Let's put the value of x 4 in this given polynomial. When you put, you will get 20 minus 20, that is equal to 4. And if you put 1 here in place of x, if you put 1, then it will be 1 square minus 5 plus 4, 5 minus 5. Again, it is equal to 0. It is equal to 0. So children, you will put 0 here. So what you have seen, children, you have seen that the degree of the polynomial is 2 and you are getting 2 zeros. So here you are deriving a very important result, that maximum zeros of a polynomial are always equal to its degree. And then children, zeros of the polynomial are 4 and 1. Both are the value of the variable x. So we have to call them with different names. The first value can be called by alpha and the second value can be called by beta. These are simply the two different values of x. So we are calling them with different name, alpha and beta. So children, I hope it is clear to everyone that how to find out the zeros of a quadratic polynomial by factorizing. Now children, let's learn more. General form of a quadratic polynomial, you know all that this is equal to ax square plus bx plus c. A is the coefficient of x square, b is the coefficient of x. Therefore, a and b are called the coefficients of variable, and this is the term without x, no variable is attached to it. So therefore this is known as the constant terms. Today we will learn what is the relation between zeros and coefficients and constant of the polynomial. If it is a quadratic polynomial, children, then sum of the zeros, alpha and beta were the root. So if you will add these two roots, the value is always equal to minus of the coefficient of x upon coefficient of x square. So this is minus b by a. And if you find the product of these two, this will be c, the constant term, divided by coefficient of x square, that is a, c by a. So you may learn it like this, minus of coefficient of x upon coefficient of x square, or alpha beta is equal to constant upon coefficient of x square. Similarly, we can derive the relation for the cubic polynomial. The general form of the cubic polynomial is ax cube plus bx square plus cx plus d. So a, b and c, they are the coefficient and d is the constant term. The maximum zeros of the polynomial are 3. Is 3. Maximum zeros of the polynomial will be 3 because the degree of the polynomial is 3. Similarly, the maximum relation that you can have are also equal to degree of the polynomial, that is 3. In the last page you have seen, children, the degree of the polynomial is 2. Therefore, you got two relations, sum of the root and product of the root. And if there are three terms, if the power is 3, the degree is 3, that means there will be 3 relations. The first relation will be taking one of them alone, that is sum of the zeros, alpha plus beta plus gamma. In the second relation, we take two roots together. So if we will move in this sequence, alpha beta, then beta gamma, then gamma alpha, and then again you will get the repeated term alpha beta. So we will not write then. So the first term of this relation will be alpha beta plus beta gamma, then gamma alpha. After that, repetition occurs. Therefore, you will stop writing, and therefore alpha beta plus beta gamma plus gamma alpha. There are always 3 terms. The degree is 3, therefore the terms are also 3. This is C by A. And the last relation, if you take 3 together, in first relation we have taken each 0 alone. In the second we have taken 2 together. In the third we will write 3 together. So if we write 3 together, the first will be alpha beta gamma, the second will be beta gamma alpha, alpha beta gamma and beta gamma alpha. They are just the same, alpha beta gamma, or you write gamma beta gamma alpha. They are just the same, alpha beta gamma, or you are just changing the sequence of alpha beta and gamma. So they are just the same, children. Therefore, we will not, whenever repetition occurs, we don't write, we stop writing. So therefore, the third relation reduces to alpha beta gamma only, and this will be equal to minus d by a. Just once again, see the pattern. If it is a first relation, then coefficient of x square b upon a. If it is the second relation, first relation is always negative. So minus of b upon a. If it is the second relation, it will be c upon a. If it will be third relation, again it is minus d upon a. First relation negative, second relation positive, third relation negative. First relation b by a, second relation c by a, and the third relation is equal to minus of d by a. So I hope you all are able to note this pattern. It always moves in a pattern manner, whether it is a cubic polynomial or it is a biquadratic. Same way you will proceed. So children, this is first relation, sum of the roots is equal to minus b by a. Sum of the zeros taken 2 together, then it will be c by a. Third relation will be negative, and you will take 3 together. Alpha beta gamma is equal to minus d by a. Now let's learn more by doing. Let's do the exercise 2.2 first question. First of all, we will find the zeros of the polynomial and then we will verify these two relations. So, children, it is 4x square minus 4x plus 1. This is a polynomial given to you and you need to find out the relation between the zeros and the coefficients and constant. To get this relation, first of all, you have to get the zeros of the polynomials. So, to get zeros, we have to put it equal to 0. So, children, let's put this polynomial equal to 0 and then taking two terms together and the last two terms together by splitting middle terms, and you will get that 2x common and it is 2x minus 1. Then you will take minus 1 common and it is 2x minus 1 equal to 0. In the take this 2x minus 1 bracket common as it is in both the terms. So children, it will be 2x minus 1 and in the other bracket is also having 2x minus 1 equal to 0. Therefore, both the brackets are same. Therefore, both the zeros you are going to get the same. Either the first bracket is equal to 0 or the second bracket is equal to 0. So if you will put first bracket equal to 0, you will get x is equal to 1 by 2 or x is equal to 1 by 2 from here also. That means both the zeros are same. Alpha is also 1 by 2 and beta is also 1 by 2. Now let's find out the relation and let's verify the formula that you have learned right now. Are they true? So children, alpha plus beta is equal to minus b by a in a quadratic polynomial. So the first root is, let's check left hand side, put the value of alpha and beta. Alpha and beta is giving you half plus half equal to 1. Let's see the right hand side. If I put the value of b and a, minus sign I am copying like this only, and in place of b I will see what is this. B is the coefficient of x, and with sign if I take, coefficient is always taken with sign, so the coefficient of x is minus 4. So that means the value of b is minus 4. So this minus is from the formula. And in place of b, you are putting the value of b, that is minus 4, and the value of a is 4. So minus minus makes it plus, and it is 4 upon 4 cancels and will give you 1. So left hand side is equal to RHS, right hand side. Therefore, this relation is verified. Now let's verify the second relation, product of the roots. Product of the root means alpha beta is equal to c by a. Again, whenever you are verifying, you have to solve left hand side and right hand side separately, and then you have to verify whether you are getting the same result from both the side. If it is there, that means this relation is verified. So children, let's put the value of alpha. Value of alpha is half. Value of beta is again half. So when you multiply, you will get 1 by 4. Let's find out the value of c by a. C is the constant and a is the coefficient of x square. So it makes it 1 upon 4. So from both the sides, the answer is same, 1 upon 4. And therefore, once again, you are able to verify left hand is equal to right hand. Therefore, this relation holds good. This is learning by doing. Since I'm saying that the formula is this, you are going to learn. This is not amazing. The amazing thing is you must check it, learn it by doing it. So let's do one more example. Let's do exercise 2.1 and let's do one more example. Suppose one term of the quadratic polynomial is missing. How to verify the relations and how to find it. So children, in this case, you have seen the t square minus 15. This is the polynomial. Therefore, the single power term, that is t, is missing. In a quadratic polynomial, first we have a term which has the square of the variable. Then we have a term with single power of the variable, and then a term without the variable. So here the term with power, single power of t is missing. So we can also write it as, this polynomial can be written as t square minus or plus 0t and then minus 15. So that you are able to understand what is A, B and C here. Now children, to get zeros of the polynomial, you have to put it equal to 0, and you have learned the identity in your ninth class that we can write it like this: square root of 15 square. Now it becomes a square minus b square. Applying this identity, in first bracket you will be writing a plus b, and in the second bracket you will be writing a minus b. So using that identity, this will become t plus square root 15, t minus square root 15 equal to 0. Since the product of 2 is equal to 0, so either of them must be equal to 0. So either the first bracket is equal to 0 or the second bracket is equal to 0. So if you put first equal to 0, t is equal to minus square root 15, and if you put second equal to 0, t is equal to square root 15. Therefore, the first 0 of the polynomial is minus square root 15, and second 0 of the polynomial is square root 15, or we can say alpha is equal to minus square root 15 and beta is equal to square root 15. Now, once again, let's verify the relation. Sum of roots is equal to minus b by a. Alpha plus beta is equal to minus b by a. Put the value of alpha and beta in left hand side and b and a to right hand side, and then verify are you getting the same result from both the sides. So alpha is minus square root 15, beta is plus square root 15. When you subtract, you will get 0. Now this minus sign is from the formula, and since no term without t, that makes b is equal to 0. So let's put the value of b, that is 0, minus 1, negative of 0 is 0. So that means left hand is equal to right hand, and therefore you can say that the relation is verified. Let's check the second relation. Product of roots c by a, alpha beta is equal to c by a. Put the value of alpha and beta, you will get minus square root 15 into plus square root 15 will give you minus square root 15. And let's put the value of c and a this side. So c is, children, a term without t. So this is minus 15. The value of c is minus 15. Put it here, and upon a, that means the coefficient of t square, that is 1. And therefore you are getting minus 15 this side also. And both the sides are equal, therefore it is verified. Now let's do the same thing with a cubic polynomial also. So this is an extra question, children. We have a cubic polynomial x cube minus 4x square minus x plus 4. Now again, you want to find out the 0 of the polynomial. So to get zeros of the polynomial, we have to put it equal to zeros. This type of question, once again, you have done in your class 9. Since you are able to take these two terms are giving you x square common, and this two terms are giving you minus 1 common. So let's take these two terms together. Take x square common, you are left with x minus 4. If you take minus 1 common, again you are left with x minus 4. So this bracket x minus 4 can be taken common. So x minus 4, and this is x square minus 1. Again you are able to see that one identity, a square minus b square, can be applied here. So this is, first bracket will be as it is. Here you are applying that identity. The identity, which identity are you using here? This is a square minus b square, which is equal to a plus b and into a minus b. So using this identity, you can break it. x minus 1 and x plus 1 equal to 0. Now there are three factors, and out of these three factors, one of them must be equal to 0 to make it equal to 0. So either this one is 0, or this one is equal to 0, or this one is equal to 0. So if you put this is equal to 0, you will get x is equal to alpha. That will becomes the value of the first 0, that is alpha. And if you put x minus 1 equal to 0, it will become x is equal to 1. That is the value of the second 0, that is beta. And the third 0 will be x is equal to minus 1. So we will call it as gamma. Since the zeros, 3 zeros you are getting because the degree is 3 here. Number of maximum zeros are always equal to the degree of the polynomial. Same is with the relation. If the degree is 3, you will get 3 relation. So the first relation is taking one at a time. Alpha plus beta plus gamma is equal to minus b by a. So if you put the value 4 plus 1 minus 1, left hand side becomes 4, and in the right hand side, first relation is always negative of b upon a. So negative sign as it is, and the value of b is minus 4, coefficient of x squared. So children, minus 4 minus and minus makes it 4. Again, left hand is equal to right hand, therefore the relation verifies, and therefore let's move to the second relation. Second relation is taking two roots together. So alpha beta, then beta gamma, then gamma alpha. Add by taking two together. So alpha beta, beta gamma, gamma alpha, and second relation is always equal to C by A. So left hand side alpha into beta, 4 into 1. Then beta into gamma, 1 into minus 1. Then gamma into alpha, minus 1 into 4. So this is 4 minus 1, and then this is minus 4. So if you will subtract, you will get minus 1 in the left hand. And let's see what we are getting in the right hand side. So right hand side is C upon A. So this is B. This is the coefficient of x cube here is A. X square is B. The coefficient of x is C. So what is the value of C? That is minus 1. So let's put minus 1 upon A. That is the coefficient of x cube. So that is 1, and therefore when you cancel, you will get minus 1. Again, from both the side, you are getting the same answer. Therefore, it is verified. Let's verify the third relation, taking all the three roots together. So if you will take all the three roots together, it will become alpha, beta, gamma. That is always equal to, first relation is minus of b by a. Third relation is equal to c by a. Sorry, second relation is c by a, and the third relation is minus of d by a, and d here is the constant term. If you take minus of it, it will become minus 4. A is the coefficient of x cubed, so this is minus 4 upon 1. Right hand side, you are getting minus 4. In the left hand side, if you will put the value of alpha, beta and gamma, again you are getting minus 4. So left hand side is equal to right hand side, and hence the relation is verified. That's all for today, children. Keep learning more.